This is Newsome News.
Hello, and welcome to Newsome News. I'm your host, Zara, and we are live. Wait, that doesn't make any sense. Our main story tonight concerns the concerning uptick in umbrella-related crime in the tri-state area. But first, do you like dungeons? How about dragons? Well, this exciting new gaming experience contains exactly one of those things. This is That Cool Dungeon Thing. To start off this story, we'll head straight to the field, and by field, I mean studio apartment of the room plotter, Zara.
Yeah, thanks, Zara. It's going all right. We're taking in the user's parameters, how many rooms they want, how big they want the rooms, all that stuff, and we're placing the rooms on a 2D grid like this. Yeah, we've got a lot of work to do to make sure the user puts in valid parameters and that our rooms don't overlap with each other. After we scatter the rooms, we've got to determine how many doors each room is going to have and then figure out a way to place those doors and represent that. And then we need to translate all of that onto another 2D array to pass on to other methods. And then...
All right, Zara, I think we get the point.
But it's really cool.
Shut the f*** up. Next, we're following a magic ball of yarn. We've got Jose here to talk about maze generation. Jose?
Thank you for the introduction, Sarah. I'm going to be talking a bit about how we're connecting our rooms together after we have generated them. So the first thing that we want to think about is we want to make sure that every single room is reachable from every single other room. And the way that we're achieving this is by implementing an algorithm known as L-shaped corridors, or also known as elbow-shaped corridors. And this is because they look kind of like a 90-degree angle. And this is because we're choosing a source point and a destination point, and we're moving one step at a time in our X position and placing a floor tile on our way. So we go on the X position, so we match our X position with the destination, and then we move in the Y direction, and we do the same. And so that's what gives our algorithm, or the algorithm that we're using, its name. And the way that we're making sure that everything is connected together is by choosing a random room to begin with, and then we, in a loop, connect that picked room with its closest neighbor. And we connect the middle of one room with the middle of the other. We create that L shape, or it can also just be a straight path. And we do that until we have chosen every single room in our dungeon. And it's actually pretty simple. And some things to note about it is that it can run through other rooms. There's nothing stopping it from us writing a hall through another room, but we can tune our algorithm to not place walls as it's traversing through another room. And it actually creates an interesting looking dungeon while it does so. So it works in our favor. So that's where we are right now. Anyways, thanks again, Sarah.
Fascinating stuff, Jose. Next, we'll turn to Tam, who will tell us about the process of transforming this 2D representation into a 3D dungeon. Tam?
Alright, so the idea is that we take in the 2D representation and create a tile map from it. Using the tile map, we can place cells, which are pieces of a room, into grids and connect them into rooms once they're all accounted for. The tile map uses the 2D representation to determine where to place the cells, as well as whether or not there should be walls in a certain direction, depending on what's the north, south, or east, or west of the current grid. It checks to see if there's an existing room or hallway in a direction, and determines if there should be a wall facing that direction. That's been Tam. Thank you very much.
How interesting. Finally, I believe we have Kathy here to walk us through some demo examples and wrap things up conceptually speaking. Kathy?
Hey Zara. Here we have a demo of the 2D representation of our dungeon. Currently, we have constants to differentiate between the perimeter, door, and interior nodes of rooms, as well as the hallways connecting them. -1 is used to represent empty space. In the actual Godot editor, we begin with the cell and check the nodes around the cell to determine which walls of each cell need to be hidden during generation. We are also setting up other parameters that can be adjusted, like the number and scale of monsters and treasure chests located throughout the map.
Thank you, Kathy. Well, you heard it here first, folks. It's only a matter of time before That Cool Dungeon Thing is the greatest storytelling tool / gaming aid on the market. Upon completion of the project, TCDT will present its users with a 3D dungeon for use as a storytelling tool for game masters at every gaming table. The GM or DM will be able to navigate through the dungeon, providing its players with a visual aid while keeping the majority of the gaming experience where it belongs, on the table. With dice, because we love dice. This has been the Newsome News Network, and we are signing off.